Hello my dear students, this is Akash SD and welcome to the ASD Physics classes students. I hope so you are doing really great. So students, in this video we are going to start the chapter vectors, and in this video we are going to see what is the vectors and what are the types of vectors. Students, this topic is very important for the 11th and 12th both point of view. Okay, so let's start this topic vectors. Okay students, so let's start it here. So here you can see students, first one what is given here, the scalar quantities here. Okay, so let's see here please, scalar quantities here. Now because first we should know scalar quantities, now then only we can see what is the vectors and how it is different from the scalar quantities, is it? So let's see students, see. So a physical quantity which can be described completely by its magnitude only and does not require a direction is called scalar quantity. Only and only magnitude, direction not required. After that, see please, addition, subtraction, multiplication or division of scalar quantities can be done according to the general rules of algebra. Whatever we know, like 2 plus 2, 4, 2 into 2, 4, 6 by 2, 3, general rules. It will be applicable for the scalar quantities here, okay? Now students, if I talk about here some of the examples of scalar quantities, you can see very well. Now very general examples are there, like distance, speed, time, mass, volume, density, work, energy, heat, power, temperature, charge, potential, whether gravitational potential, electric current, etc. And this electric current, later we will discuss about it also in a detailed manner here, students. Okay, so this is what, this is about the scalar quantity, and here only what matters, here only magnitude matters, direction does not needed. There is no need of any direction in this scalar quantities here. Next one, students, after learning the scalar quantities, now we will see the vector quantities. This is the main thing for us in 11th and 12th, even in further classes also after 12th. So see please students, vector quantities here. So see, a physical quantity which has magnitude as well as direction and obeys the triangle or parallelogram law of vector addition is called a vector quantity, students. So here we have to remember that one thing, a vector quantity magnitude is there, direction is also there, but these two things are not enough. We need one more thing, and what is that? Triangle law or parallelogram law. This rule should be also obeyed by the vector quantity, then only we can tell this is a vector. Only magnitude and direction is not enough. Okay, this triangle law or parallelogram law we will study in a detail in further videos. Now after that, see please, addition, subtraction or multiplication of vector quantities cannot be done according to the general rules of algebra. Then what to do? Then here, students, we need it is done by the vector algebra, that we will learn one by one how to do vector addition, subtraction, multiplication, how many kinds of products are there. Now all these things we will see that here. Now students, after that, what are the examples of vector quantities are there? Very basic, like you can see, displacement is there, velocity is there, acceleration is there, momentum is there, whether linear momentum, angular momentum, impulse is there, linear impulse, angular impulse, whatever kind of impulse, force is there, very common, torque, gravitational field intensity, etc. Okay students, so what I have told you, vector quantities means it will have magnitude, direction, and it should follow triangle law of vector addition, or we can tell parallelogram law also. Okay students, good. Now next one, let's see. So now, as I have told you, now we'll discuss about the electric current. Now let's see here. So see here, students, very important. Electric current has both magnitude and a direction. Magnitude means 1 ampere, 2 ampere, 3 ampere. Direction means always conventional current, always flows from positive terminal of the battery to the negative terminal of the battery. So direction is also fixed, magnitude is also there. But why it is a scalar quantity? Why? Because it does not obey the vector algebra. That means in a simple language we can tell it will not obey the triangle law of vector addition. That's why electric current is the which quantity? Scalar quantity. Kindly remember it. Next one, students, here. Now how to represent the vectors here. Now first we'll see the graphical representation, then only we will go to the mathematical representation. Okay, so see here, students, see. Graphically, a vector is represented by a straight line with arrowhead on it. Again, I am telling that here, see, straight line, and that straight line should have arrowhead. Now, after that, the length of the straight line, what I am telling, the length of the straight line represents magnitude and the arrowhead represents direction. Okay students, so this thing we have to remember that for the graphical representation. Okay, now let's see some examples how to graphically represent the vector here. See, a man is running with a speed of 5 meters per second. In which direction? In which direction? In east direction. Can be represented graphically as. So which direction is there, students, here? East direction. So for that we should know the basic direction convention like this one here. Basically in physics we follow this: east, west, north and south. Okay students, so whenever we have to draw the vector, we need what? Magnitude and direction. Magnitude means length, straight line, and direction means arrowhead here. So in which direction, students? East direction, 5 meters per second. So here we have to take one scale. Now, scale should not be too small also, scale should not be too large also. So here what I am considering here, let's take for example, I am considering this 1 meter per second is equivalent to how much? 1 centimeter. Okay, so when we will draw here the line, now let's take here, I have drawn here one line. Okay, so this line represents the magnitude here. How much line should be there? 1 meter per second means 1 centimeter. That means 1 meter per second, 1 centimeter. So 5 meter per second, how much? By the basic rule, we can tell 5 centimeter, and this 5 centimeter line very easily we can draw here. Okay, so let's here please, if I draw here please, now 5 centimeter. So here please, here, this is 0. I'm just giving the numbers 2, 3, 4 and here 5. Now arrowhead in which direction? Which direction? East direction. That means here like this. This arrowhead. Okay. That means this vector represents what? This vector represents speed in which direction? East direction with how much? 5 meter per second, because here 5 centimeter is there. Okay. Now students, next one. Second one, let's see here. See, a force of 100 Newton is acting on an object in which direction? In northeast direction can be represented graphically as. So can you guess very well northeast in which direction? Like this here, please students, see. This is the northeast direction here. Which direction? Northeast direction, and this angle used to be how much here? 45 degree. But if you take the scale, students, here, for example, 1 Newton, 1 centimeter, then you can't draw 100 centimeter line on the paper, is it? Then what we have to do, students, we have to just take some normal, we have to think. So 20 Newton I am taking here, 20 Newton I have taken here 1 centimeter. Even you can take 25 Newton also 1 centimeter, no problem here. Okay, so 20 Newton 1 centimeter means 100 Newton how much? Just guess and tell. 100 Newton how much here? 100 Newton will become here 5 centimeter. If in case you are taking 25 Newton 1 centimeter, then 100 Newton means how much? 4 centimeter. Okay, now this line we have to draw in which direction? Northeast direction. This is the northeast direction here, na? So let me draw here northeast direction like this, northeast direction. Okay, how much length? 5. So again here please, here 0, 1, 2, 3, 4 and let me go here 5. This is there. Now arrowhead in which direction? This direction, northeast direction. If you put arrowhead in this direction, then it will go southwest here. Okay, so arrowhead will represent the direction and this line will represent what? Magnitude. That is what? That is the graphical representation. Okay, great. Now students, let's see here please, types of vectors. Very, very important. Actually, so many types of vector is there, but very few very important types are there that we needed in physics. Okay, so let's see the students, the types of vectors. First one, parallel vectors. What are the parallel vectors? Let's see students, parallel vectors. See, two vectors are said to be parallel if they have drawn in same direction. They have drawn in same direction. Magnitude may or may not be equal here. Now here we will make it here two situations, when magnitude equal and when magnitude not equal. Okay, so see please here. If magnitude is also equal, then parallel vectors can be called as which vectors? Equal vectors. Okay, so let's see one by one here. First one, what I am telling here, if the magnitude is not equal in same direction. So let's take, I have written here like this here. Two vectors I have drawn here like this here. No? In same direction. Magnitude is equal, magnitude is not equal. Let's take here, this is vector A and this one I have written vector B. This is the just symbol. A vector this side here. Don't draw like this. Don't draw like this. Okay, arrow should be in this direction, in this direction. Okay, great. So here you can see very well, the direction is same but the magnitude is not equal. So here students, we can tell here this angle. Theta is 0 degree angle concept we will learn in the further videos, but here remember that Theta how much? 0 degree here. So they are called which vectors? They are called here, students, which vectors? Parallel vectors. Which one? They are parallel vectors. Parallel vectors here. No? Parallel vectors here. Okay, great. Next one, students, let's see here, please. Next one. If I talk about here, second situation, let's take here. If I draw like this here, let's take. This is the vector A as I have told you, and let's take here. Now I have taken here, this is vector C. Okay, vector C. So here also what will happen that here, angle anyhow, the theta is 0 degree, but you can see direction is same and magnitude is also same. That means here we can tell that here, we can write even in a mathematical form also, vector A is equal to vector B. And they are called which vectors, students? They are called here equal vectors. Equal vectors. Okay, remember that please. Equal vectors. Now, very, very important point. See, all equal vectors are parallel vectors. But all parallel vectors are not equal vectors. Whenever you will think logically, you can understand it very well. This point, very, very important. Okay. Next one, after that, what is coming here? Anti-parallel vectors in the same way. Let's see, please. Anti-parallel vectors. Two vectors are said to be anti-parallel if they have drawn in which direction? Opposite direction. Magnitude may or may not be equal. Same scenario. Again, see, if magnitude is also equal, then anti-parallel vectors can be called as which vector? They can be called as opposite vectors here. Here what will be there? Direction will be opposite. Okay. Now in the same way, again we'll do here, we have taken vector A, B, C. Now we'll go for the next one here. So see here please, students. Now again, let's take for example again, this is vector A. Now BC already I have taken, now I am taking here D. Let's take like this here, D. So here what is happening that, students, here the angle, if I talk about the angle, theta will be 180 degree, opposite direction. Okay, direction is opposite, but can you see the length of the vector is same? No. So this is called which vector? This is called, students, anti-parallel vectors. Which vectors? Anti-parallel vectors here, anti-parallel vectors. Okay, now next one, guess please what we are going to do. Next one, let's take it again. This is vector A, and now I have drawn here like this here, vector E. So here you can see direction is opposite, but the length is same only. That means here also angle how much? Angle is same only, 180 degree here. But they are called which vectors? They are called here opposite vectors. Okay, they called which vectors? They are called opposite vectors. Okay, and even if we want to write also in a mathematical form also, we can write here this one, vector A equal to minus of vector E. Minus of vector E here. Here also you can write vector A equal to minus some integer and then vector D here. Now all these things we will study in a later also, no problem. After that, students, some important points are there under the note. You can see here, all opposite vectors are anti-parallel vectors, but all anti-parallel vectors are not opposite vectors. Okay, just think logically, you will just get it. Okay, great. See how much easy we are going. Next one, students, see please. The third one is which one? Co-planar vectors. Co-planar vectors. Here please. Two or more than two vectors are said to be co-planar if they lie in the same plane here. Okay, so here I have taken here some plane. Let's take here. This is X, this is Y. So this is my XY plane here. After that, if I take here, this is Z. So this is which plane, students? This is which plane? This is the XZ plane. Which plane? This is XZ plane. This is which plane? This is XY plane. And after that, if I take this one here, this is which plane? This is called YZ plane. YZ plane, XY plane, and which one? XZ plane. Now, students, in this, if I take here some vectors, let's take for example, here I have taken vectors. This is vector A, this vector B, and here I have taken vector C. This I have taken vector D. In this plane, let's take vector E, and let's take here vector F. Like this vectors we have taken here. Okay, students. So now, students, if I talk about here A and B, vector A and vector B, they are lying in a which plane? XY plane. Which plane? XY plane. XY plane. That means what? They are co-planar. Co-planar. Okay. Similarly, after that, if I talk about here, let's take for example vector A and vector C. Guess and tell me please. No, just you can comment also. Vector A and vector C. Vector A in xy plane and vector C in which plane? Xz plane. That means they are non-coplanar. 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 Okay, similarly, one more example. If I take here vector C and for example vector E, that is also what is, students? That is also non-coplanar here. Okay, so you can see very well, students, in a very easy way. A and B coplanar because they are in xy plane. C and D coplanar because they are in xz plane, and even E and F is coplanar because they are in a yz plane. If you see A or C or maybe C or F, they are non-coplanar vectors here. Na? Very easy, very easy, very easy. Okay, great. Now students, next one, very, very important vector, unit vector. Which vector is there, students? Unit vector. Let's see please. A vector whose magnitude is 1. Magnitude how much? 1 and points in a particular direction is called which vector? It's called the unit vector. Now, to find out unit vector in the direction of vector A, we divide the given vector by its magnitude here. Let's take for example, students here. Let's take this is vector A. This is vector A. So now students here, vector A means we want the unit vector in this direction. So we'll write like this. We will tell A cap or A hat. So vector A by magnitude, mod A, or even if you wish, you can write like this also, vector A by A. Okay, so this is there. After that, now here we can little bit simplify also. That means we can write here vector A means mod of A into A cap. That means any vector is represented by magnitude and direction. And what is the magnitude of the unit vector? Mod of A cap, how much here? This is 1 here. Okay, great, very easy, very easy. Now, we are just reaching to the end here. See, note, along positive x-axis, I cap is taken as unit vector here. Positive x-axis means I cap. So, negative x-axis means minus I cap, opposite vector. Similarly, positive y-axis means j cap. That means negative y-axis means minus j cap, again opposite vector. Now, along positive z-axis, how much? K cap is taken as unit vector. That means along negative z-axis, minus k cap. So again, students, I am telling positive x-axis, y-axis, z-axis means I cap, j cap, k cap. Similarly, negative x-axis, y-axis, z-axis means minus I cap, minus j cap and minus k cap. And you know very well what is the magnitude of all these vectors here. See whether I cap is there, whether j cap is there, whether k cap is there, even minus I cap, minus j cap, minus k cap. All are having magnitude how much? 1. Very easy. Now students, zero vector. What is zero vector? See please, a vector whose magnitude is 0 and direction is not defined. Direction is not defined. It's called which vector? Zero vector. It is denoted or indicated by which one? Vector 0 here. Okay, sometimes even net force is 0 now. So we'll write here vector F equal to vector 0 here. Okay, very easy. Now students, after learning all these vector, scalar quantities, types of vector, let's see one basic question. See, a vector is drawn along positive x-axis with magnitude 8 units. Write it in vector form here. So here magnitude how much here? 8. Direction is what? X-axis. So students, see please, we know that what I have told you. See, I have told you here vector A equal to mod into A cap. So in the same way, if this is the vector A, magnitude how much here? 8. Positive x-axis means direction 8 I cap. So we can write here vector A equal to 8 I cap, whatever unit. Okay, great. Second one is students, second one what is given here? See please, a vector is drawn along negative y-axis with magnitude 5 units, right, in a vector form here. Again, so let's take a now vector B is there here, vector B. So mod B into, let's take B cap, small letter here. So what this vector B will become here? Magnitude how much here? 5. Negative y-axis means what to write here? Minus j cap here. Okay, and here also what is there? Here